So up to the last class, do you have any doubt, anyone? I hope no. So the last class we are discussing about gears, okay, gear drives, okay. So there we have seen like what is gear, okay. These are kind of machine element and where it is used, okay. What are the different characteristics or what can be done or what are the possible implementation areas of gear drive, okay. So those things we have discussed. So there we have seen that basically this particular machine element is generally used for like transmitting motion from one shaft to another, okay. And apart from that, like motion conversion in the form of like directional change, okay. And similarly like velocity ratio can be also changed, okay. So all those things already we have discussed, and we have seen that basically there is no slip in that uh, while the transmission of motion is taking place by the application of gears, okay. So then there is no slip because of the positive because of the, I can say, successive engagement of the teeth, and there is no slip, and that's why these gear drives are also known as positive drive, okay. So also we have discussed about the limitation of the application of gear drives by the central distance, okay. So generally this application of gear drives, it is limited to high central distance or low central distance, larger central distance, or
Low central
comparatively
distance.
lower compared to belt drive or other type of flexible drives, belt drive, rope drive, etc. What do you think? Application of gears. So generally, in case of gear drive, central distance between the two shafts, it is comparatively higher or lower, lesser or larger. You can tell me.
Low, sir.
Hmm? Yes, please repeat.
Low, sir.
Low. Okay. Okay. So for other higher central distance, we generally go for other type. So later on, we have also seen about the friction wheel and how to represent the gears in a pictorial view. All these things we have discussed, and also later on we have obtained the relationship between the like the size of that particular gear and the speed, okay, speed of rotation. So there we have seen that basically it's inversely proportional to the speed of that particular gears, okay. They are actually inversely proportional to the radii of those gears, okay. So size dependency we have seen here, okay. So now today we will be going for different classifications of gears, okay. So okay, so there are like different types of classifications of gears which can be done based on like based on the, I can say, the straight. Let me share another screen. Okay, so it's visible, right?
Yes, sir.
Okay, okay. So now gears, okay. So there are different classifications of gear based on different positions, okay. One can be like based on the relative positions of the suffixes, that can be one type of category. And apart from that, we also have other types like on the basis of velocity of the drive also we can categorize them, okay. And on the basis of like position of the axis of the shaft we can assign, okay. So there are maybe different classifications. So first of all, let us see what is the classification of gears which can be done on the basis of velocity of the drive, okay. So now this velocity we are talking about that particular peripheral velocity, this PP that we are talking about, okay. So in terms of the, so now in that case, okay, based on the velocity of the drive we can categorize these gears like the low speed gearing, medium speed gearing, and high speed gearing. And what are the permissible values, and when we are going to call it that particular gear type as a low speed gearing, okay, or medium speed or high speed. So for low speed gearing, the velocity of the drive is up to 3 meter per second, and for medium speed drive that is 3 to 15 meter per second, okay. So and for high speed drive that is the 15 more than 15 meter per second, okay. If that is the velocity of the drive, then we call it as high speed drive, okay, high speed gearing. So in that case you might be wondering, we know that generally your gear, that's a rotating element, in most of the cases rotating element, right? that shafts are rotating, and like from on that shaft the gears are mounted. So gears are generally rotating element, and from one gear to another gear we can transmit motion by successful engagement of that. Okay, engagement of the teeth, particular teeth. So we call that as meshing. Okay, yesterday we have discussed. Okay, meshing of two gears. Okay, or sometimes mating. Meshing or mating of gears. Okay, this is the better one. Okay, for saying that engagement. So in that case, we know that this is rotational, the nearly rotational element. Okay, so that means the angular velocity we are talking about was, what is the unit of angular velocity? Radian per second. But here you can see we're talking in terms of meter per second. So then really in that case we are talking about the peripheral velocity here. Okay, that's why it is in that. Understood? So similarly, on the basis of position of the axis of the shaft, we can also categorize the different gears. Okay. So now can actually work. That is the intended purpose is like transmission of motion or power from one shaft to another. Okay. So in that case, do you think that a single gear can do this work? Anyone? If I have a single gear, okay, so is it going to work the thing that is intended?
No, sir.
Oh, so there must be minimum of
Yes,
how
sir.
many gears?
Five
Two
to
gears.
two.
Yes,
Sir, two.
there should be. Yes, there has to be minimum of two gears. Okay. Now only if I have two gears. Okay, let's consider I have two gears now. Okay, gear one and gear B. So if I just have those two gears, okay, is it going to work?
Sir, one is to rotate, sir.
Okay, now let's consider. Okay, one gear is rotating. Okay, so I have two gears. One gear is rotating. So is that drive going to work?
If they are
No,
meeting,
sir.
it will work.
Yes, yes. Requirement is minimum there has to be two gears, and definitely they should be properly matched. Okay, so they should be mating gears, two machine gears. And for proper matching of gears, okay, actually there are like other some of the later on we'll discuss about like module has to be same. Then like teeth profile also has got certain you can say application on that and all. Okay, but it has to be two machine gears. Okay, so. There only we can say that if one of the radar is rotating, our intended person, that is the rotation from one shaft to another shaft through the engagement, proper engagement of the gears, okay, that will happen. Okay, up to this much, I hope it's clear. So now in that case, now depending on the position of the axis of the shaft, that means what we are talking about, position of the axis of the shaft. So ultimately, with respect to the axis of the shaft only, we know that on that shaft the gears are mounted here, right? So now whatever is the, what if we are talking about suppose a gear like this, okay, now whenever we show like this, so this position is nothing but the axis position. That means from this side the shaft is there, okay, onto which the gear is mounted. Understood? Okay, so the center of the gear as well as the, or you can say axis of the particular shaft, it becomes the same because it passes through here. Yes, understood. So now we know that minimum two gears has to be there. Ultimately, that means two subs we are talking about. So now, depending on suppose it is gear A, suppose we have gear B sub here. So now, what is the condition of the two sub? Based on that, also we can consider. Okay, consider the categories the gear drive. Okay, so based on that, we have got like we may have different situation. One may be like we can have parallel sub, right? So parallel sub, all of you understand? So parallel shaft means suppose one shaft like this, okay, another shaft like this, okay. So here, whatever is the distance here also it is the same. Okay, so they are equal. So now this is the parallel condition. So sometimes what may happen from one shaft to another, we have to definitely have dimension transfer that we are talking about interested in. Okay, and they're parallel to each other. So in that case, so in those kind of situation, we can have different use of different gears. Like we can use spar gears, which is the most common one. Most of the time, whatever gears that we are going drawing, okay, we are actually drawing the spar gears. Okay, we can also use rack and pinion, which is a another special type of gear arrangement. Okay, we can also use different helical gears, herringbone gears, etc. Okay, that is applicable for parallel shaft. Next, sometimes what we may have one shaft here. Okay, from this direction to suppose this direction. Okay, we need to have the transfer of motion. So in that case, that is the
Sir,
intersecting shaft. Okay, so these two, if you consider
sir,
the axis of these two shafts, so this is the axis of shaft A, and this is the axis of shaft B. So they are intersecting here. Okay, so in this kind of situation, we can use the most like we can go for bevel gears. Okay, so sometimes we can also have the situations like we can have skew shaft that is non-parallel, non-intersecting. Okay, so like let's consider one of the shaft is going in this direction. Okay, another shaft is suppose from above it. Okay, it is coming in this direction. So they are like there is this distance apart. Okay, so they are not intersecting. So they are neither parallel nor intersecting also. In those cases, we have the useful. We can use the worm and worm gears. Okay, so in your EM engineering mechanics, maybe in this lab, okay, you might have seen the worm and worm wheel, correct? You have seen one element like this, one gear kind of element, okay, suppose like this, okay, and you might have seen one screw like element which was somewhere here. Yes,
Yes, sir.
okay, so that was nothing but was the worm and worm wheel. So here you can say which one is the, suppose this is A, let's consider this element is B. Okay, so for the element A, okay, so which one what is the direction of its axis or shaft direction?
sir, can you repeat?
So for this diagram I am talking about, okay, so I am considering this element as screw element as element A, and this the gear as the element B, the wheel element as the element B. Okay, so now what I am asking is, so for the element A, what is the direction of its shaft axis? Where is the shaft axis of the shaft?
X-axis, sir.
So it is like x-axis is right now I have not designated like x or y, okay, but this horizontal line, okay, in this direction we have got the axis of it, okay, correct. Okay, and what about B? What about B? This element.
Y, Y-axis, sir.
You cannot say like y, okay, this is not in this direction. Y will be if you suppose x, okay. If this is the x, then y will be in this direction. Okay, but right
Left
now it is
side.
there. So this is into the plane, okay? Yes or no?
Yeah.
That way, like if you try to on this particular screen of your laptop or mobile, okay? So if you just go try to go downwards, okay? That way we have the direction. Understood? This, like this way it is going into that plane, okay? Understood? Yes or no?
Yes, sir.
So it
Yes,
is
sir.
means
The
left
element
side,
it has
sir.
got the thickness,
So
right?
it's moving along with the X and the X-axis, sir.
Please repeat.
So it's moving along the X-axis with body A.
No, right now I'm not. Right now we are not interested in that particular movement. I'm just asking you to let's locate the axis. Okay, axis of this body A and body B. Okay, so for this case, okay, this direction
Yes,
is
sir.
this is the axis, no problem. You have a proper up. Okay, so for this, if you think of as a three-dimensional structure, so it has got the thickness of it, right? It has got the thickness on the here only we have got the teeth. Okay, so now this way as if this is the z-axis, as if if this is the x direction, okay, if this is the z, okay, so as if this is the z axis, along the z axis you can consider as if it has got the axis, okay, if this direction is x, this is y, so understood, so into the plane. So now in that case, do you think this particular axis of this particular shaft, okay, and this one, are they parallel? Are they parallel? Definitely not. Okay, this is here. Okay, this is that. Okay, are they intersecting?
No, sir.
No,
Okay, so they are neither parallel nor intersecting. Okay, so that's that's why this is the case. Okay, understood.
yes, sir.
Yes,
Okay,
sir.
okay. So now prior to discussing in details about these different types of gears, okay, so let's consider about the different gear materials which are generally used in for manufacturing different gears, okay. So now this particular selection of gear material actually depends on several factors like the type of service, that means where you intended to use that particular gears, okay. So what is the peripheral speed of that drive, okay, that will be required in that particular application area, and similarly what are the different manufacturing methods available for manufacturing that particular gear, and like the degree of accuracy you intend to get out of that particular gears, okay. So based on all those things, all those different parameters, apart from that we have other like application influencing factors like the availability of that, okay, that material, or like different application areas, okay. So that size, etc., all those things are also dependent. So now, type of service means like all of you can understand the type of service, like whether you are going for high speed application, high temperature application, like high loading application, or like that. Okay, so based on that, to withstand that particular service condition, you have to properly select the gear material, out of which that means you are going to manufacture that particular gear. Apart from that, depending on like what is the peripheral speed up to which that will be applicable. So based on that also, if it is high speed gearing, if it is low speed gearing, etc., okay, or ultra high speed gearing, based on that, like the same material you cannot use for that, okay. So similarly, like degree of accuracy means like if you take the example of the different small gears like that is there in your wristwatches, okay, or maybe if you think of the accuracy that is required in some gears, okay, which is just like in the toy cars and all that is there. So based on that also, like you can, like depending on what is the degree of accuracy, you go for different material, okay. So now the common gear materials which are like the nail and used in the engineering applications, they use they like include a variety of steels. Then cast iron is one of the very one is the important one, okay. We have got bronze. Then apart from this metal, okay, metallic elements, so we can also make gears of different non-metallic materials like even woods, okay. So previously in the agriculture sectors and all, wood gears were there, okay. Similarly, in the it can be made of out of textile, different polymers, etc., etc. Okay, so that will depend on like where you are going to use. Okay, so you might have seen in your toy cars and all there are like some small gears. Those are made out of plastics or different polymers. Okay, but if you think of like the gears that is there in your lathe machine and all, so that cannot be made out of polymers, right? So depending on the service condition, depending on the loading condition, etc., whatever is required, based on that you have to properly select it. Now like this gear material, that's steel, okay. See, generally it's one of the strong and highly resistant type of material, and that can be very easily machined with the required level of accuracy, and it is also useful for transmitting heavy loads, okay. So that is useful. That means whenever you require like that means steel, if you select as the gear material, it can give you like this capability. And one of the very material, that is the cast iron, is one of the very mostly widely used, okay. And why it is generally behave like a very good gear material, because of its good wearing properties and excellent machinability it has got. Apart from that, the castability of that particular material also is very good, okay. So that means it can be cast in any desired form very easily. That's why it is one of the very popular type of gear material, okay. And whenever if you think of like withstanding very heavy sliding loads and all, okay, if that is the your requirement service condition, then your bronze will be one of the very ideal gear material, okay. And generally, because in in normal cases like in the worm and worm wheel, okay, generally we encounter this kind of heavy sliding loads. That's why those gears of your worm and worm wheel generally are made out of bronze. Okay. Apart from that, as I have already said, different polymers nowadays, other different materials that is also coming up. Okay, so all those things can be utilized. But for that, like there has to be a particular manufacturing method for that particular gears. Okay, so in your different manufacturing related subjects, you'll be studying about the different ways by which will be able to manufacture gears, like gear hopping, shaping, etc. Different gear manufacturing methods are there. Okay, and so based on that particular method which you are going to use, also you have to select that particular gear material. Okay, so but first and foremost, it is the that is mostly dependent on the service condition and the requirement, the speed and like the loading requirement, etc. Okay, understood.
Yes, sir.
Yes, sir.
Okay, so up to this much, any
Yes.
confusion, anyone?
No, sir.
No, sir.
Okay, so all of you have understood, right? Okay, so now then, now based on this data, okay, so we'll just go for a very small problem, okay, very basic one. We'll see like how by this time already we know about the velocity ratio, okay, and we also know its dependency on the size and all, okay. So based on those data, we'll just see how we can find out like we're going to solve a very small problem. Okay, is that okay?
Yes, sir.
Okay. So now, what does the problem statement say? It's a very easy one. There are two spark gears. Two spark gears have a velocity ratio of 1 by 3. So velocity ratio is given. So now we already know there are like two driven gears or ultimately driven shaft also we can say, and like driving gear or driving shaft. If it is written in terms of shaft, or if it is written in terms of wheel, or if it is written in terms of gears, okay, they are having the same meaning, because sometimes the gear only we call it is like gear wheel or like that. Okay, or ultimately we know if whatever is the shaft velocity, okay, driving shaft velocity, the driving gear is keyed to that particular shaft itself. So that's why whatever is the velocity of that particular shaft, that itself is the velocity of that particular gear which is mounted on that particular shaft. Okay, so don't get confused. Sometimes in some question the speed of the shaft might be given, in some condition, in some question it might be written like the speed of the wheel, in some question it might be written the speed of the gear or the speed of the pinion, depending on that. Okay, don't get confused. So now there are two sparks which are properly meshed, okay, and they have a velocity ratio of 1 by 3. So it is given that the driven gear has 72 number of teeth, which is of 8 millimeter module. Okay, it is rotating at 300 rpm. You have to calculate the number of teeth and the speed of the driver. Also, you need to find out what will be the pitch line velocity. Okay, now I think for this particular problem to solve both the parts, actually the understanding of module also is required, which we'll encounter once again later on. But today I'll just show it. Okay. So now this suffix one and two that we'll be using for driving and driven gears. Okay. So generally one is for driving or ultimately the input. Okay. Two is for driven gear. Okay, so now what is given? So driven gear has 72 number of teeth. So T2 is given, okay, as 72. Okay, velocity ratio is also given 1 by 3. So VR stands for velocity ratio here. Okay, not partial reality and all, 1 by 3. Then it is said that the driven gear is rotating at 300 rpm. So once again, N2 is given 300 rpm, and module of the gear is given as 8 mm. So small m stands for module. Okay, m is equal to 8 mm. So later on we will once again discuss about, when we will discuss about module and all. Okay, then also you'll be able to understand. So now we know this velocity ratio. Okay, that is nothing but can be written as n2 by n1, or in terms of omega also it can be written omega 2 by omega 1, which is itself is equal to n2 by n1. Okay, and we know that they are related to the number of teeth as well as the size of the particular gear, okay, in a inverse ratio. So equal to T1 by T2. Okay, we have seen like R1 by R2. Okay, so the number of teeth also is related like that. Okay, so now that is given as 1. They are already given. Okay, so from there we'll be able to very easily find out n1, the required n1 and n2. Okay, so n2 is already there, so n1 is twice 3 times n2, that means 3 into 300, that is 900 rpm. Similarly, t1 becomes 1/3 of t2, so t2 is given as 72, becomes t1 becomes 24. So this completes the initial part. Okay, next also it is up to this much. Is it clear?
Yes, sir.
The given data we have to utilize. Okay, also they are finding what will be the pitch line velocity, that is
Yes,
p
sir.
suffix p that they are asking about. Okay, what is that? So now we know pitch line velocity pp is nothing but that is the linear velocity we are talking about. So it is r1 omega 1 I can write, or itself is equal to, in terms of the other gear if we discuss, that is equal to r2 omega 2. Okay, so that is what is written. Okay, r1 omega 1 or r2 omega 2, that is up to you which one you use. We already have the data. So omega, it is 2 pi r by 60. Okay, so that is there, and r means that is the radius we are talking about. So in terms of diameter it is d1 by 2. Okay, so actually on this module, okay, module term later on also we'll discuss in details. So this understanding of module is required here. So like actually this mt by 2, okay, diameter is actually, so module is actually d by t. Okay, so module is actually is given by d by t. So that is this understanding we're using here. Okay, so so now in terms of, I can write, in terms of d I can write mt, right? D equal to, because m equal to d by t, module equal to d by 2. Okay, so d is nothing but m into t. Okay, so right now here it is t becomes t1. Okay, and now other points are already given. N1 I know, t1 I know. We are just substituting the values and we'll get the answer. Now you might be wondering like why it is in terms of millimeter per minute that we are writing. So module is in millimeter. Okay, so why in terms of module millimeter per minute? Because here while using omega we have not divided by 60. If you directly divide it by 60, then automatically in terms of millimeter per second you will get, okay, 2 pi n by 60. Okay, you do that, then in terms of millimeter per second you will get. So ultimately the answer is 9.04 meter per second. That is the pitch length velocity. Here second part, in the second part just you need to have the understanding about the module. Okay, module is equal to d by t. Understood? So this problem is solved. Let me know.
Yes.
Okay. Okay, so for today, then we'll do one thing. We'll stop here. In the next class, we'll discuss in details about the different spar gears, like the spar gear, where it is used, how you can identify like and pinion, helical gears, bevel gears, etc., etc. Okay, so this will stop here for today. I'll be taking the attendance now, and some of you are joining very late, so everything is it's being recorded, and so actually everything is already being monitored. Okay, so don't take this for granted advantage. You should not so do like I'll at the towards the end of the class we'll just join and we'll get. Okay, don't think like that. Okay, so respond to your name calls. Nilutpal,
Present, sir.
Shankar,
Present, sir.
Arsisman,
Present, sir.
Rehan,
Present, sir.
Partha,
Present, sir.
Rishikesh,
Present, sir.
Hermiki,
Present, sir.
Nahasal,
Present, sir.
Teza,
Present, sir.
Rishikesh, Nat,
Yes, sir.
and Emil.
Yes, sir.
Okay. So thank you, everyone.
So
Thank you, sir.
Thank you, sir.